The lost secrets of Roman engineering, how they built for eternity. Picture this. You're standing on the Appian Way in Rome, your feet touching stones laid down over 2,300 years ago. Cars rumble past on this ancient highway, their tires gripping the same volcanic rock that once felt the sandaled feet of Caesar's legions. Above you looms the Pantheon, its massive concrete dome defying gravity and time itself, having weathered earthquakes, floods, and the rise and fall of empires. Meanwhile, in your hometown, the road you drove on this morning is already showing cracks after just 5 years. The answer lies buried in a conspiracy of silence that lasted over a millennium. A deliberate destruction of knowledge that nearly erased the greatest engineering secrets in human history. When the Western Roman Empire collapsed in 476 CE, invading barbarians didn't just destroy buildings. They systematically hunted down and killed the master engineers, the architecti and magistry, who carried these secrets in their heads. Libraries burned, workshops were abandoned, and the oral traditions passed from master to apprentice vanished like smoke. For centuries, medieval Europeans stared in wonder at Roman ruins, convinced they were built by giants or supernatural forces. They had no concept that mere mortals could create such enduring marvels. But recent archaeological discoveries and cutting-edge scientific analysis have finally begun to crack the code of Roman engineering genius. The Romans saying, "all roads lead to Rome," wasn't just a metaphor, it was an engineering boast. At the empire's peak, over 250,000 miles of roads crisscrossed 3 continents, many of them still functional today. But here's what will shock you. These weren't just roads. They were military weapons, economic lifelines, and technological marvels disguised as simple pathways. The secret began underground, in a process so meticulous it would make modern highway engineers weep with envy. Roman road builders didn't just lay stones on dirt. They created a multi-layered system that would make a modern foundation contractor jealous. First came the statumen, a foundation layer of large stones carefully fitted together without mortar, creating a stable base that could flex with ground movement without cracking. This wasn't random stone throwing. Each rock was individually selected and positioned using knowledge of load distribution that wouldn't be formally understood by engineers until the 19th century. Above this came the rudis, a layer of broken stone mixed with lime mortar, followed by the nucleus, a concrete-like mixture of gravel and mortar. But here's where it gets fascinating. The Romans didn't just use any limestone for their mortar. They had discovered that volcanic ash from specific locations around Mount Vesuvius, called pozzolan, created a chemical reaction with lime that produced a concrete stronger than anything we use today. The top layer, the summum dorsum, consisted of carefully fitted stone blocks, often made from basalt or other volcanic rock. These weren't just placed randomly. Roman engineers understood concepts of crown, the slight arch that helps water run off, proper drainage, and load distribution. Each stone was cut to precise specifications and fitted so perfectly that many Roman roads never needed mortar between the surface stones. But the real genius was in what you couldn't see. Roman roads included sophisticated drainage systems with culverts, side ditches, and carefully calculated gradients that channeled water away from the roadbed. They understood that water was the enemy of any structure, and they designed their roads to fight it at every level. Now, prepare yourself for the most mind-bending revelation of all. The Romans invented a concrete that could self-heal underwater and actually grew stronger over time. When modern scientists finally analyzed samples of Roman marine concrete in 2017, they discovered something that shattered everything we thought we knew about construction materials. The Romans had figured out how to create what we now call biomimetic concrete, a material that mimics natural processes. Their secret ingredient wasn't just pozzolan, but a specific type of volcanic ash that contained a mineral called tobermarite. When this ash mixed with lime and seawater, it created a chemical reaction that continued for centuries, actually strengthening the concrete over time while simultaneously filling in microscopic cracks. Modern concrete begins to deteriorate within decades, especially in marine environments. Roman concrete structures submerged in seawater for 2,000 years are stronger today than when they were first built. The lime clasts in Roman concrete, which modern engineers initially thought were signs of poor mixing, are actually designed features that act as self-healing agents. When cracks form, these lime clasts dissolve and recrystallize, sealing the damage automatically. This discovery has sent shockwaves through the modern construction industry. We've been trying to recreate Roman concrete for years, but we're still struggling to match their results. The Romans weren't just building structures, they were creating living materials that could adapt and repair themselves. The Pantheon in Rome represents perhaps the most audacious engineering achievement in human history. Its dome, spanning 142 feet in diameter, remained the world's largest unreinforced concrete dome for over 1,300 years. But here's what makes it truly impossible. It shouldn't be standing. According to modern structural engineering calculations, a concrete dome of that size and age should have collapsed centuries ago. The Romans built it using techniques that we're only beginning to understand. The dome isn't uniform. It's a masterpiece of graduated engineering. The concrete at the base contains heavy aggregates like travertine and tuff, providing strength where the structural loads are greatest. As the dome rises, the Romans gradually switched to lighter materials, using pumice and eventually hollow clay pots near the top. But the real stroke of genius was the oculus, the 30-foot opening at the dome's apex. Modern engineers initially thought this was simply for light and ventilation, but recent analysis reveals it's a crucial structural element. The opening actually reduces the dome's weight while creating a compression ring that holds the entire structure together. The Romans understood principles of structural engineering that wouldn't be formally recognized until the Renaissance. The Colosseum reveals another layer of Roman engineering brilliance. This wasn't just a big amphitheater. It was a sophisticated machine designed for crowd control, entertainment logistics, and public safety. The arena floor could be flooded for naval battles, then drained, and filled with elaborate stage sets lifted from underground chambers via a complex system of pulleys, counterweights, and trapdoors. The seating system could accommodate 50,000 spectators and empty completely in just 15 minutes through a carefully designed network of corridors and exits called vomitoria. Here's where the story takes a darker turn. The fall of Rome wasn't just a political collapse. It was an intellectual catastrophe. Roman engineering knowledge wasn't written down in books. It was passed through apprenticeships, guild secrets, and hands-on experience. When the empire fell, these human libraries were scattered to the winds or simply killed. The invading Germanic tribes had no use for engineers who could build roads and aqueducts. They wanted warriors and farmers. The sophisticated supply chains that brought pozzolan from Italy to construction sites across the empire collapsed overnight. Local quarries were abandoned, and the knowledge of which stones worked best for which purposes was lost. Christianity, ironically, played a role in this loss. Early Christian leaders often viewed Roman engineering achievements as symbols of pagan decadence. Many Roman buildings were deliberately dismantled, their stones used for churches and other holy structures. The technical knowledge embedded in these buildings was literally carved apart and scattered. For nearly 1,000 years, European builders used cruder techniques, creating structures that barely lasted decades, while Roman ruins stood as mute testimony to a lost golden age of engineering. The renaissance of Roman engineering knowledge began in the 19th century, but it's accelerating rapidly today thanks to new technologies. Ground-penetrating radar has revealed the sophisticated foundation systems hidden beneath Roman structures. Chemical analysis has unlocked the secrets of Roman concrete. 3D modeling allows us to understand the complex forces at work in Roman domes and arches. Scientists at MIT and the University of Utah are now trying to recreate Roman concrete recipes, not just for historical curiosity, but because Roman materials might be the key to creating more sustainable modern construction. If we could build structures that last 2,000 years instead of 50, we could dramatically reduce the environmental impact of construction. Recent discoveries continue to astound researchers. In 2019, archaeologists uncovered a Roman road in Britain with a foundation system so sophisticated it included multiple layers of different stone types, each selected for specific drainage and load-bearing properties. The precision of Roman surveying has been revealed through laser mapping. Roman aqueducts maintained consistent gradients across hundreds of miles, with elevation changes calculated to fractions of inches per mile. Standing before Roman ruins today, it's easy to understand why medieval people thought they were built by supernatural forces. The Romans achieved something that goes beyond mere technical skill. They created structures that seem to transcend the normal limitations of materials and time. But perhaps that's the final secret. Roman engineering wasn't just about technical knowledge. It was about understanding that buildings and roads weren't just functional objects. They were investments in eternity. Every stone was placed with the assumption that it would need to serve not just the current generation, but dozens of generations to come. Modern construction is driven by cost-cutting, planned obsolescence, and quarterly profit reports. Roman engineering was driven by imperial pride, religious devotion, and a profound belief in the permanence of their civilization. They built as if their empire would last forever. And in a sense, through their engineering marvels, it has. The next time you see a pothole in a road that's only 5 years old, remember the Appian Way. The Romans didn't just build roads and buildings, they built monuments to human ambition, testaments to what's possible when engineering skill meets unwavering commitment to excellence. Their ruins whisper a challenge across the centuries. If they could build for eternity with primitive tools and ancient knowledge, what should we be capable of today?